So now that we've seen a couple of examples, now we're going to really turn the screws and have three transformations that are taking place rather than just two. So we've back to sine again. So we have a sine function. There's no number in the A position, so our value for A is going to be 1 for our amplitude. Period, remember again, period is 2 pi divided by B. So that's going to be period is 2 pi divided by, and the B value is 1/2. But when we divide by a fraction, we instead multiply by the reciprocal. So we're going to end up with 2 pi times 2 over 1. So our period is 4 pi. Vertical translation, the plus k. So this time we're translated up 2 units. So that means we're going to have a horizontal dotted line at 2 on this one that's going to serve as our 0 line. And then finally our phase shift is that 2 pi, that h. So that means our graph is going to be moved to the right 2 pi units on the x-axis. So to graph, we've got to label our axes. So in the horizontal direction, we'll go ahead and go to that 4th tick mark for whatever the period is. This time that's 4 pi. So that means if we go back halfway to the 2nd tick mark, that's 2 pi. Or in other words, every single one of our tick marks is pi. So 3 pi for the 3rd one, and so on from there. We'll label a couple more points in a moment. In the vertical direction, we've got that vertical translation of 2. We have an amplitude of 1. I'm going to keep it simple and just count by ones this time. So we'll go 1, 2, 3, 4 going up. And so I'm going to put in that horizontal dotted line at 2. That's going to serve as our 0 line for this graph. And so now we just have to figure out where that starting point of our function is so that we can start to plot in the points and get our curve sketched. So I've got a phase shift of 2 pi. So instead of starting my graph on the y-axis, I need to go to the right 2 pi. Sine starts its cycle at 0, but again, because of the vertical translation, we're going up to that dotted line that we made, and so that's going to be the start of our cycle. And then from there, it's the same as we've done on the other sine functions. I'm going to count over 4 spaces on the x-axis, and that's going to be the end of my cycle. Halfway in between the start and finish of the cycle, sine is at 0. Halfway in between the first and second zeros, sine's at a maximum, so the amplitude this time is 1, so we're going to go up 1. And then halfway in between the second and third zeros, we're going to be at a minimum, so that's going to be 1 below that line. And so now we've got our first period sketched. And we could probably do that a little better. Let's try that one more time. Oh, close enough. And now if we go backwards a cycle, again, recall in a previous video I had said that we want to make contact with the y-axis. So instead of extending going forwards, I'm going to extend going backwards. So I'm going to count back 4 spaces on the x-axis. 1, 2, 3, 4. There's going to be my dot. So that's the start of the preceding cycle. Between the start and the end of the cycle, I'm going to be at 0. Halfway in between the first and second zeros, I'm at a maximum. Second and third zeros, in between those, I'm at a minimum. And so now I've got the other period sketched. So the other thing that we should do is we should label the x-axis to at least the start and end of our graph. So that preceding spot there, if we're counting by pi's, this is going to be negative pi at that, or sorry, negative 2 pi at that location, since we're counting by pi for every tick mark. And then the last point of our graph there is going to be at 6 pi. So for our last example where we're sketching the graph, we see we're back to cosine again. So we're going to be starting at a maximum, ending at a maximum. Although this time we have an amplitude of 5, but that 5 is negative. So that means we're going to have a reflection. So instead of starting at the top and ending at the top, like our parent cosine graph does, we're going to start at the bottom and end at the bottom. For our period, we have something in the B position, so we're going to take our period, calculate that by dividing 2 pi by pi over 4. So like on the previous question, we're going to take 2 pi and multiply it by the reciprocal. And so we can see that the pi's are going to cancel out this time. So we have a period of 8. So this time we actually won the lottery, because instead of counting by pi's or pi over 2's along the x-axis, we're going to be counting by integer values. We're going to be counting by whole numbers. Vertical translation, there's no number in the k position in our equations. We don't have one. But we do have a phase shift. So that phase shift is that number h, in this case 2. So I need to number up my x-axis, and like I said, the numbers are very user-friendly on this one. We're fortunate with a pi in the b value. That means that you're going to end up with integer values along your x-axis. So I'm going to count out to the 4th tick mark and label it with an 8. So I'm still not going to count by 1s. I want to count by 2's in this case. I want to always make that 4th tick mark whatever the period is. So that means every tick mark is 2, so 2, 4, 6, 8. I can go ahead, since it's easy enough, label out a few more. I can even go into negative territory here. So now my x-axis is really all set. Now I've got no vertical translation, so I'm going to be centered on the x-axis. So I've got a phase shift of 2, so that means instead of starting on the y-axis, I'm going to have to slide to the right 2 units. But now, instead of starting at a maximum for cosine like it does with the parent function, we're going to be reflected. So we're actually, because of that negative sign, we're actually going to start at a negative. We're going to start at the bottom, and it's going to be at a negative 5. So I have to go over to 2, down to negative 5. So we can label up our y-axis. Don't want to forget that. And so now that's going to be the start of our graph. And so then because of the reflection, we're starting at the bottom and then ending at the bottom. So I'm going to count over 4 tick marks. 1, 2, 3, 4. That puts me at 10. So that's going to be where the next one's located. That's the end of the cycle. Halfway in between those 2 points, cosine would normally be at a minimum, but because we're reflected, we're going to be at a maximum. So we're going to be up here at 5. And then halfway in between the maximum and minimum points, cosine is always at a 0. So there's our graph. We could go forwards, but in order to make sure that we make contact with that y-axis, I'm going to go ahead and extend backwards. So I count back 4 tick marks, and end up with our start of our preceding cycle here at negative 6. Halfway in between those 2 bottommost points, we're going to be at the top. And then halfway in between the maximum and minimum points, we're going to be at, whoops, wrong spot there, at our zeros.